Hello again. So today I've got a new solar charge controller. Well, it's actually a wind charge controller, but I'm going to be using it for solar. It's a PWM one, and it works by using a dump load. It operates at 20 kilohertz, or so it says. So I'm going to connect up to a power supply and test it. It came from here. It wasn't that cheap either, but I was needing something that operated at quite high frequency because the solar charge controller I've got interferes with my battery charger if the solar panels are producing more than the battery charger can actually take away, and it just throws up an error message and stops charging. And it came from Karasuli Technology. So I'll connect this up and get it tested. Not seen that chip before. It must be a microcontroller of some sort anyway, and it's got a 7805 voltage regulator and what looks like a programming port, but I don't think I'm going to play with that because I've no idea what that microcontroller there is. If it is an Atmel microcontroller I might have a look at it, but it's not, so there's nothing really I can do with that. And the screen for it is just your typical LCD module. Okay, so it's just connected up to a power supply here. What you want to do is, before you actually connect a dump load, you must connect it to a battery first, just in case you connect it up to a battery that's fully charged and the dump voltage is not set right and it ends up dumping loads of power. So switch it on. So you could see the voltage that the power supply is actually at and the dump voltage, which is 14.8 there. So the little blue potentiometer, you can just turn this, and as you can see the voltage is changing. So I'm going to turn it right the way up and see what I can actually set the voltage to, because sometimes my batteries in winter especially are very cold and I have to get them up above 32 volts because it's a 24 volt system I use. So I'm going to see what the maximum is. The guy says it was about 33, I think, and he was exactly right. It goes right up to 33 volts, so that's perfect. So each day I'll just need to measure the temperature of the batteries and then set the appropriate voltage. So I'm going to connect a small heater to this and we'll see if it dumps power and see what happens. Okay, so we've got 16.8 volts on the power supply, so I'm going to turn this down a little bit until it starts dumping. And you can actually hear it, and it shows how much of the energy has actually been dumped, so that's very good. And the heater is heating up. So it says it's only dumping 33%, and if I was to turn that down more, that would go up. So I'm going to disconnect the dump load and see what the lowest voltage you can put this to actually is. So it turns out this charge controller is actually extremely versatile because you can set it from 0 volts all the way up to 33 volts. So this is anything from a 1 cell lead acid up to, well, 12 cells. And not only that, you could use it for lithium batteries as well, provided that you've actually got a proper battery management system attached to that. Now the only thing that really worries me about this charge controller and all other dump load charge controllers are if these fail and it's a bright sunny day, then your batteries are going to get fried because obviously it won't be dumping the power. So I think I need to develop somehow a high voltage cutoff, so like if the batteries hit 32 volts, it'll cut them off permanently, and like till I come back into the shed and see what the fault is, because you could destroy a battery bank with these if you don't have proper management if this was to fail. So we'll put it in the shed and then replace the old one. The weather has been quite crap this whole week, so there's not much power coming in, but it should be enough to at least do a test. So this is my old charge controller. it seems to use entirely analog electronics. It doesn't have any microcontrollers or computerized stuff in it at all. And that way it's really good, but as you can see, it just dumps like once every second. And the noise is, well, it's just a magnet I've put in there, so I've got an audio indication of when it's actually dumping. And there's warm water in here, which is heated up quite well. But this is the maximum voltage you can put it up to, which depends on how much sunlight is coming in, but it usually sits at 29.4 at 100 watts, but if the sun really comes out, that voltage actually goes up. The batteries today are at 5 degrees Celsius, so at 5 degrees Celsius they should really be getting charged to 30.8, because if you looked at my temperature compensation video, this charge controller isn't really good for the batteries. It would be fine in summer, because in summer sometimes they're up at about 25 degrees Celsius, so they'd be okay in summer for this charge controller, but this charge controller is pretty much useless in winter, so I'll get it taken off and then replaced. This charge controller I'd actually modified myself. I'd replaced the MOSFETs, they were originally surface mount, but I've replaced them with IRFB 4110 to take more current, and also put a much bigger diode on there facing round the other way, so it was actually heat sinking to a metal bar. It was actually screwed onto the wall, but I'm going to modify it again just to put a standard heat sink on the back. The solar panels are directly connected to the battery anyway, so it's still working without a solar charge controller. I'm just using a grid tie inverter to get rid of the excess power. So here's the battery voltage coming up to set voltage, so that's beginning to dump now. And as you can hear, it's making a bit of a funny noise. So that shows how much the power has been dumped. Most of it is going into the battery. So probably if I took that magnet away, or still making the noise. Doesn't really bother me that much, but I'll probably take the magnet out. But yeah, that's good. That means that I can actually properly equalise my batteries now without having to connect them up to a power supply. Now I could do it all from the solar charge controller if there's sunlight. The only problem I've got is these MOSFETs are actually getting roasting hot. So I think what I'm going to have to do is either put a bigger heatsink on them or use a dump load with a higher resistance, because that's meant to be a 12 volt heating element, and with 30 volts going through it, it's going to be taking a heck of an amps on the pulses. So what I'll do is I'll put my inverter on to divert away the power, and then I'll see about sorting out my dump load. So what I've done now is connected the bottom dump load in series with the top one. So the one on the top is 300 watts and so is the one on the bottom. I've connected them in series, and because the resistance is now higher, these MOSFETs are only just a little bit warm to the touch. So that's a lot better. But it's not an ideal solution, because I was wanting to have two separate dump loads, so like I can have a really small one for boiling eggs or whatever that'll heat up quickly, and I can have the bigger one for heating water during the day. But this I'll have to do just now. Well, after much shouting, swearing and soldering, this is the finished product. The MOSFETs are actually IRF3205, but they're still a lot better than what was on there. I've simply removed the old MOSFETs, put a wire for gate drive onto here, and just linked them all together in parallel, and it's all heat sinked against this enormous heat sink here. So that should do. I've already powered it up in the house and it did seem to work, but I haven't actually tested these MOSFETs yet, so here goes. Well, we're just waiting for it to go up to the set voltage and then we'll see if it actually works. And that sounds to me like it is working. So that's really good. So that means that I could go back to using just one heating element rather than connecting them up in series. Well, it all seems to be working now, but I think these MOSFETs are still dissipating a fair wee bit of power because this whole back plate is now warm. Well, it seems that they're actually still dissipating quite a lot of power, so I had to put them back in series to offer a higher resistance, and it isn't getting as hot. So I think what I'm going to have to do is maybe try and find a different type of MOSFET, probably the IRFB 4110, because they're using a lot of things and they don't tend to get that hot. So my temporary solution until the new MOSFETs arrive is just this blower in here, which is blowing air over the heatsink, and it's now freezing cold. These blowers, by the way, they're actually brilliant. They're £2 each off eBay. They're 24 volt, but I've managed to get them up to 32 volt and they still run quite well. So that's a good product to look out for. Just search for 24 volt blower on eBay and you'll be able to get these very cheaply.